Given a matrix, there's an unknown a in it, and we're asked to show that the determinant is 6 minus 3a. So I'm going to expand along the first row. I'll get 2, and then it's going to be positive because it's in the first row, first column. It's minus 1 to the power of 2 when I add the row and the column together. And then I'll get minus 1, 1, 2a as my next determinant. Then I'll minus 1, cross that out, times this determinant, 1, 1, 2a. For the final one, it becomes back to being a 2, because it goes plus, minus, plus, or you can do just minus 1 to the power of the row plus the column. Cross them out, I'm going to get 1 minus 1, 2, 2. Because I haven't gone into detail on where that comes from, but you've just got to trust the process here and practice it. I should have said that that is det A. So then we do minus 1 times A, minus 2, minus 1, A minus 2. I'm doing this minus this, plus 2, 2, minus minus 2. That's going to be, oh yeah, that's not going to cancel, that's going to become 4. So I get minus 2a, minus 4, minus a, plus 2, plus 8. Minus 4 plus 2 is minus 2, plus 8 is 6. And I get my 6 minus 3a. Great. Just to say, you don't have to expand about the first row. If I did the first column instead, then I'd get 2, 1, sorry, minus 1, 1, 2a like before. But then here, I'd get minus 1, and I'd cross these out, and it would be 1, 2, 2a, because I get a minus because it's now in the second row, first column. And then for this one here, it's back to being a plus. And if I cross this out, I'll get 1, 2, minus 1, 1. You'd get exactly the same answer. In fact, you could expand, it's worth practicing this, expanding about maybe the second row or even the third column. We'll get the same answer. Sometimes there's advantages because if there are lots of zeros, if there was like a 0 here and a 0 here, it'd be really good to expand about the third row. Here, there's not really an advantage, so I've just gone with the first row. State the value of a for which a is singular. So it's singular when det a is equal to 0. So it's just going to be 2. And now, given that it's non-singular, which means it has an inverse, okay, that's the other word for it. If it's non-singular, it has an inverse. Find the inverse of a capital A in terms of a. So let's write down that the inverse is 1 over det A times by the transpose of the cofactor matrix. Now you might have seen in textbooks that sometimes they find the matrix of minus and then they go for the cofactor matrix, but I'm going to go straight for the cofactor matrix because there's only one extra step. We just have to include a plus, minus, plus. That's the only difference really, and it goes like this. And what I'm really doing is doing minus 1 to the power of the row plus the column. That's how you get this pattern. So in a 2 by 2, you get plus, minus, minus, plus. In a 4 by 4, plus, minus, and so on. And then for the first one, I basically just cross out the row and the column that the 2 are in. By the way, you have to do it this long way because there's an A in there. We can't put this in our calculator. So just take your time with it, I'd say. You can also actually just get rid of the pluses. It might be a bit more confusing. We know they're positive. That's the main thing. Yeah, I'm just going to keep going for it now. So I'm going to get this out. 1, 1, 2a it will be. And for this last one, 1, minus 1, 2, 2. Then 1, 2, 2a. Then I will cross this one out, 2, 2, 2a. Two, 1, 2, 2. But there's a minus there, remember. Finally, I'm going to get 1, 2, minus 1, 1. Two, 2, 1, 1, but there's a minus there. Finally, with the a, I'm going to get 2, 1, 1, minus 1. Okay, let's work out what that is. I've got minus a, minus 2. Then a, minus 2, but I'm doing the minus of that, so actually I'll get 2 minus a. Then 2 minus minus 2, that will give me 4. A minus 4, but I'm doing the minus of it, so 4 minus a. 2a minus 4. 4 minus 2, which is 2, but the minus of that, so I'll get minus 2. 1 minus minus 2, so 3. 2 minus 2, which is 0, the minus of that still be 0. Then minus 2 minus 1 gives me minus 3. So I'm going to go straight to the inverse from here. We've got 1 over the determinant, which from before was 6 minus 3a. And I'm going to be multiplying by the transpose of the cofactor matrix. So what this is I basically just swap these terms. If it was element in the first row, the second row, first column, it becomes the first row, second column. Okay, so some of them stay where they are, but otherwise they swap around like that. So I'll get minus a, minus 2, 4 minus a, 3. Then 2 minus a, 2a minus 4 stays the same, 0, 4 minus 2, and minus 3. And that is our inverse in terms of little a.